Yes, I did. Hey guys, welcome back. I was bored at home, so I made this tower of toilet paper with all the toilet paper that I have. I'm kidding. I barely have toilet paper. So, if you have enough toilet paper, just throw me some over. Okay, so today we're gonna continue. This is a continuation of the previous video that we did yesterday, and we're continuing with the topic of perimeter. Now we're gonna make it a little bit more complicated today. Not complicated, but I was thinking yesterday that whenever I give you a problem that involves perimeter and whole numbers, you're excellent at it. So if I tell you that the width is or the length is 15 and the width is 9, you're very quick to figure out the perimeter because you know that you have to add all the sides and boom, you have the perimeter. However, when I give you a problem that involves decimals or fractions and perimeter, you guys all freeze up and you think you cannot do it. But let's think about this for a minute. You are very good at perimeter, at finding perimeter because you've learned the rules. You are very good at adding and subtracting decimals because we've done it since the beginning of time. And you're very good at adding and subtracting fractions because we've been practicing for the past few months. So if you're good at all three separately, why can't we be good at all three combined? So let's review decimals. Let's review finding perimeter when we are given the values in decimals and fractions. So we have a rectangle here, and just for the sake of this exercise, we're gonna say that the length of the base it's 9.6 centimeters, and the height or the width is, let's say, 3.2 centimeters. Okay, and I ask you to find the perimeter of this rectangle. First thing it clicks into your mind: perimeter. I'm finding perimeter. I have to add all of the sides. I have to combine or add all of the sides. So next step, you apply the rule. This is a rectangular shape or rectangle. Dang it. Okay, so you know that if this side is 9.6, this side is 9.6 as well. And if this side is 3.2, this side is 3.2 as well. 3.2 centimeters. So now you have all the values, and I like to see it this way because it reminds me that I'm looking for perimeter and that I have to add all of it. Okay, so there are two main ways to find the perimeter here. Two main mathematical calculations. You can do it whichever way you want. So let's begin by adding all of the sides. So I take 9.6, 9.6, 3.2, and 3.2. And you guys know by the way we do this in the classroom that I like to do my additions this way because it saves me steps and I have all the values right there in front of me, and it's easier for me. But you can very well add 9.6 plus 9.6 and then add 3.2 plus 3.2 separately and then combine those two results or add them. Or you can do it like this. Okay, so 6 and 6 is 12, and 12 and 2 is 14, 14 and 2 is 16. I carry the 1, and now I drop the decimal point because remember we're adding decimals, and when we add decimals, the decimal point has to be lined up. Remember how much we talked about working neatly in our math? I mean, not just writing numbers all skewed and just twisted. This is why it's so important to work our math very neatly, because when we're adding decimals, we need to have each value, each digit under the correct one to have the place values correct, and so that we can drop the decimal point here where it goes. And so I have now 9 and 9 is 18. 18 and 1 is 19, that is 22 and 25. So my perimeter is 25 centimeters. the perimeter of this rectangle. The other way that you could have done this is because you figure out that 9.6 and 9.6, you have it 2 times, is the same value 2 times. So you can do 9.6 times 2 and 3.2 times 2. And then you can add these two results. So let's see. 6 times 2 is 12. Carry the 1. And 2 plus 9 is 18. And 1, 19. And in this case, because we're multiplying, let's remember the rule. When we multiply with decimals, there's no need to line the decimal point. The need is to, at the end, count the decimal places that I have. And I have only 1.6. 6/10. So I put my pencil here and I write the decimal point right here. The one decimal place that I have on top, that's the decimal place that I'm gonna, run my decimal point over. So this is 9.2 centimeters, and 2 times 2 is 4, 3 times 2 is 6, and again I have one decimal value here, or decimal space, so I'm gonna run 1 here, 6.4 centimeters. And now I have to add these two numbers and see if I get the same result. You notice why I like the other way better? Because, it's just one step. Here I have to do a lot of steps. So 19.2 plus 6.4. And look at how I wrote, or where I wrote the 6.4. Okay, you cannot, and we talked about this, you cannot come and write 6.4 like this, because this is addition, and in addition we have to line up the decimal point. So the first thing you have to do is write the decimal point right there, and now write 6.4, and you add. This is 6, this is 15, carry the 1, and this is 2, and what do I do with the decimal point? I drop it where it is. And look at that, 25.6 centimeters, 25.6 centimeters is the same result. Okay, so there is no need to think that you cannot find the perimeter when I give you a problem that involves decimals, because we all know how to work with decimals. All you have to do is take a deep breath and say, okay, this is just the same that I do with whole numbers. It's just that I have to think about the decimal rules as well. Okay, so let's look at another example with fractions. Okay, let's say now that we have this rectangle, and let's say, just to make it easier, let's say that this is 9 centimeters, and this is 3 and 3.5, 3 and 1/2. So the baseline, the length is 9 centimeters, and the width, or the height, is 3.5. And I ask you to find the perimeter. Okay, first thing, you say, okay, perimeter, I have to add all the sides. And because I know this is a rectangle, this value is the same as this. And this value is the same as this, 3 and 1/2. Okay, now all I have to do is add 9 plus 9, the two 9s, plus 3 and 1/2 plus 3 and 1/2. You see what I did? I grouped my values, and if you want to do it even neater than that, you can put parentheses just to separate the two sets of values that are the same. But you have to leave this plus sign here because you're adding all of the sides. Okay, so what do we have here? We have two whole numbers, 9 and 9. Can we add 9 plus 9? Of course we can. And for 5th graders, this just turned into a PEMDAS problem, right? So 9 plus 9 is 18. So I'm going to drop this plus sign here too, because I'm solving it like I would a PEMDAS problem. And now I have two mixed numbers here. 3 and 1/2 is a mixed number, and it's mixed. We say mixed because it has a whole number, whole value, and then it has a fraction. The two digits together form the number, so it's mixed. So what can we do when we have a mixed number? Well, we can take the two whole parts, and we can add them, or whatever the operation is. We can add them or subtract them. In this case, we're adding them. So 3, we can add to 3. 3 and 3 is 6, right? Esto casi no se ve. Hold on. Let me change the... Okay, so 3 plus 3 is 6. 6. And what can we do with the fractions? And here's where you get confused. These two fractions, what do we notice about them? That they have the same denominator. And we learned that when fractions have the same denominator, I can just add or subtract the numerator. Add or subtract. I didn't say anything else. Add or subtract the numerator. So because I'm adding here, I can just go ahead and say, oh, 1 plus 1 equals 2. 2 over, and the denominator stays the same, 2 over 2. Okay, the denominator doesn't change when it is the same. So 3 and 1/2 plus 3 and 1/2 became 6 and 2 over 2. And now what do we have? We have a whole number here and we have a mixed number here. Again, what can we do with the whole numbers? We can go ahead and add them because we're adding. And 20 and 18 plus 6 is 24. And then this fraction, I can write it over here. So the result is 24 and 2 over 2, or 2/2. But what do we know about fractions where the numerator is the same as the denominator? You're taking 2 parts out of 2. So that becomes 1 whole. So 2 out of 2 is the same as 1 whole. And this 1 whole, I can add it to this 24. And what is the result? 25 centimeters. This is the answer to our question. Okay? Again, all we did was add fractions. Now, if it just so happens that the fractions that you have here do not add to a whole, then you can report your result with a fraction. Okay? And in the practice that I'm going to give you after this video, you have an example like this. Okay? I'm sorry, not after the video, but in the Google Classroom. So there's going to be a problem in Google Classroom where these two fractions do not add to one whole. Okay? So you can just perform the operation like you would, and then report the result with whatever fraction you end up with. Okay guys, so the challenge for today's video involves our school. So this is a picture of our school in Google Earth. And as you can see, the gym here, it's kind of a rectangular shape. Well, everything is a rectangular shape, but we're gonna take the gym today and we're gonna calculate the perimeter of our gym in meters, okay, of our gym building. So to do that, I'm gonna click this little ruler here, and it's gonna give me the option to measure in meters. So the measurement is gonna be in meters. Okay, so what I'm gonna do is I'm gonna stand in this corner and I'm gonna measure from here to here, and it says 39.46. You can see it right here, 39.46. So 39.46 meters, or 39 and 46 hundredths. So that's your first measurement, right? And now I'm gonna take the next measurement from here to here, and it is 15.31 meters. Okay, so write those two numbers, and with those two numbers, you're gonna calculate the perimeter of our gym building, and you're gonna put it in the comment section. Now, I want you to do the addition. I mean, if you want to add all the sides together, or if you want to add 2 first and then 2, or if you want to do it with the other multiplication, using multiplication, you can do it whichever way you want. But I want you to show me your steps. So if you do it on a piece of paper and you want to snap a picture and post it in the comments, that's cool. Or if you want to share it with us in Google Classroom, go ahead, because after this I'm heading out to Google Classroom and posting homework and a couple of other individual practice exercises that you can do to practice this. One of them includes fractions as well. Okay, so anyway, complete this, put it in the comments, and head to Google Classroom. Okay, good. Next video, it's still gonna be perimeter, but in the next video we're gonna try to figure out the perimeter of irregular shapes. And when my 5th graders, I know that we did this, and you guys went all like, I don't get it, but we're gonna take it one step at a time. Okay, and 4th graders, don't be afraid, I'm sure you can get this. Okay, so see you on episode I don't know, whatever comes next. Bye. Peace.